Algebra 1 review, problems 14, 15, and 16. Here we go. Students helping move books in the library. He fills a crate with books, each of which weighs 7 ounces. The total weight in ounces plus the crate is here in the table, and the number of books. Well, we know that every book weighs 7 ounces. We also know that my output, the total weight, is equal to 7 ounces times the number of books plus the weight of the crate. Let W equal the weight of the crate. So let's pick some number. I don't care which number. Okay, if we have 8 books, the total weight is 76 ounces. So, and we could use any of these. If my total weight is 76 ounces, and that's equal to the weight of 8 books, that's 7 ounces each, plus the weight of the crate, then 76, this total weight is equal to 7 times 8, 56, plus W, the weight of the crate. Now I want W by itself because that's what I'm trying to figure out. I subtract 56 from each side. What do I find? 76 minus 56 is 20, and that equals the weight of the crate. The other way we could do it is work backwards. 5 books, 55 ounces. 4 books, subtract 7 ounces. 3 books, subtract 14 ounces. 2 books, subtract 21 ounces. 1 book, subtract 7 ounces. 0 books will give us the weight of the crate. Many ways to do a math problem. They all give us the same answer, or there's a mistake somewhere. Let's move on to problem 15. 15. The length in feet of a small train is modeled by this function, where C is the number of cars. Well, if C is the number of cars, and we have a locomotive, 8 feet must be the length of each car. So the initial conditions look something like this. 15 feet. Let's say we have 3 cars. Then my first picture is going to look like this. Then the cars are changed, and now we have a longer train. So what I drew first was the initial conditions, a locomotive and 3 cars, each of which is 8 feet long. But then we keep the same locomotive and each car is longer because they tell us that it is. What describes the change in the situation? Did the locomotive stay the same? Yes, it did. Locomotive did not change its length, so now we're down to A and B. Each passenger car is now 8 feet long? No, it changed. It tells us it changed. So this is the answer. Please do not ever be scared or intimidated when you have a lot of words. Do not say to yourself, that's too much to read. Why? Because a lot of people will quit. But good mathematicians will try to draw a picture from the words, and they'll figure it out. Problem 16. And once we read it, this was the easiest problem we've done so far. The table represents a hurricane's distance from land as it approaches. Time is our independent variable, remember that. Distance from land, we start at 350 miles. At the end of 1 hour, it's at 325 miles. Then after 2 hours, it's 300 miles, and so forth. What does the slope of the situation represent? Well, change in y over change in x, change in distance over time. In this situation, we have the slope represents how fast the storm comes ashore. How fast the storm comes ashore. How fast the storm approaches land. Cost of staying at a hotel can be found using this function where D is the number of days and F of D is the total cost. Price includes a one-time cost for breakfast if the guest prepays for it. If breakfast is not included, which is true? Well, here's my number of days. Here's my total cost. With breakfast, without breakfast. So if I stay 0 days, my cost is $20. If I stay 1 day, my cost is $90 plus the 20, it's $110. 2 days, 90 times 2 is 180, plus 20 is 200. 3 times 9 is 27, plus 20 is $290. We are increasing at $90 every day. Without breakfast, 0, 0, 1, 90, 2, 180, 3, 270. Now we can compare. $20 more with breakfast, $20 more with breakfast, $20 more, $20 more. If we do not include breakfast, is the cost $20 less or $20 less per day? We calculated it. The total cost is $20 less.